No. 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 Boring. No, we want to watch this. I don't really want to.
Playoff game.
No.
Chance it found its way into a 19th century arch window?
Hello?
First things first, if you tell anyone about this phone call, you'll regret it.
What?
I've stolen your sneaker.
Who is this?
It's actually pretty comfortable, by the way.
I'm calling the cops. Who is this? And give me my cat back.
What? It's not a cat, it's a sneaker. If you ever want it back, you have to pay me money.
The driver might have been waiting to a crash on the west side a couple of days ago. We need to talk to him. I got over 30 employees, so off the top of my head, I don't know.
Someone stole my cat. Scruffles?
You know the guard?
Yeah.
Yeah, I read their brochure.
I don't know what to do.
Carlos?
I know.
We're going to reinstall a Panasonic job.
Call the cops.
Okay.
Hello? Hello? 911? Hello?
I'm still here, and by the way, it's a sneaker, not a cat.
What?
Fixing yourself.
Be right back. I'm gonna go to get a snack. Okay. Maybe the TV will take my mind off of this. What? Bam.
Hi! Are you having trouble with your math problems?
Yeah!
Well then call now! I can help you!
What?
That's right! Just call now and I can help you with all your math problems! Just call. Again, that's
Hello?
Hi. Hello? I need help with math.
If you need help with math, press 1. If you want to be featured on a commercial, press 2. And if you're just calling, press 3. Please hold while we connect you to a representative.
Oh, they hung up.
Did you call?
How'd you get in my house?
Don't ask questions. Just show me what you're trying to tell me. So he sent you a text saying, give me 1.23 times 10 to the 11th power dollars. Oh! Looks like you have a case of scientific notation.
Seriously?
Do you know this number? It's the speed of light. Or what about this number? It's the mass of a dust particle. Scientists have developed a shorter method to express very large numbers. This method is called scientific notation. Scientific notation is based upon powers of the base number 10. The number 123 billion in scientific notation is written as 1.23 times 10 to the 11th power. The first number, 1.23, is called the coefficient. It must be greater than or equal to 1 and less than 10. The second number is called the base. It must always be 10 in scientific notation. The base number is always written in exponent form. The number 1.23 times 10 to the 11th power. The number 11 is referring to the exponent, or power of 10.
Oh my gosh, how's that possible?
I know, it's cool, isn't it? But for those of you who need a little longer to process information, let's slow it down a bit. Let's start with the names of the parts of the equation. The coefficient is the first number in scientific notation equations. It must be greater than or equal to 1 and less than 10. For example, in the number 5,130,000,000, the coefficient is 5.13.
Wow!
The base in scientific notation equation is always, no matter what, 10. The base is the second number in the equation. The base is always written in exponent form.
Oh my gosh, really?
The exponent is the number attached to the base. It refers to how many steps you had to make from the decimal point to get to the coefficient. For example, in the number 5,130,000,000, the exponent would be 9 because the coefficient is 5.13.
How's that possible?
5,130,000,000. That's a mouthful. What if I told you that there would be a much easier way to say that number? 5,130,000,000 is a very, very long number. And as you know, there's a decimal point at the end. Now, what if we move that decimal point in between the 5 and the 1? The number would become 5.13. That's not enough. 5,130,000,000 can become a much shorter number. You just have to move the decimal point all the way to a number that's larger than or equal to 1 but less than 10. For example, 5.13. That's called the coefficient, as we learned before. Now we have to multiply it by the base, or 10. But that's not enough either. We have to add an exponent to the number 10. I hope you were counting. Do you remember how many times we went from the decimal point to the coefficient? That number was 9. That is our exponent, because that is how many times we jumped from the original decimal point to our new decimal point. So our new equation is 5.13 times 10 to the 9th power. Simple as that.
Oh my goodness.
Did you know that scientific notation can come in positive and negative numbers?
You're not serious.
That's right. Let's say you had the number, I don't know, something like this. I'm not even going to try to pronounce it. We can shorten that by a lot. All you have to do is do the same exact thing. Move the decimal point back. Because we're in the negatives, we move it back till we get that number. Like 6.15. Now, we have to multiply that by 10, of course. But since we went 8 places, it's not just going to be 10 to the 8th power, because that would be our normal positive number. We're in negatives, so it has to be negative 8, 10 to the negative 8th power. Does that make sense?
Wow!
But what if somebody gave you this equation? Would you be able to figure out what number it was? It's simple. All you have to do is take the coefficient and put the decimal point either forward or backward, depending on if it's a positive or negative exponent. For example, if someone gave you this equation, 3.14 times 10 to the 6th power, would you be able to figure out what number that is? Correct! It's 6,104,000. Let's try a negative. What about 6.12 times 10 to the negative 4th power? What would that be? It would be 0.0000612. Simple as that.
Wow! No!
Yes, now I know how to get my sneaker back. Come now, I have the money.
I have your sneaker.
What? Anna, but you're my best friend. Why?
Because it was comfortable, so. But now I'm tired of it.
That's so mean. Give it back.
Wait! Can I have some of the pie in the fridge?
No. Oh,
I forgot my sneaker.
oh, Franklin, my feet just weren't complete without you. Oh, come on, Frank. Come on, Frank. Get on my foot. Come on, Frank. Frank. Okay.
Now that's cool.
Yeah.